Here are the solutions for the review to the Chapter 1.1 and 1.2 test. Here is number 1. When we first look at this, we need to realize that we have some fractions in here. And anytime we have fractions and we're trying to solve an equation, we definitely want to get rid of the fractions. So to get rid of the fractions, I am going to multiply by n, because that is my common denominator. When I multiply by n, I'm going to be distributing to each and every term in the parentheses. And essentially what that's going to do for me, let me get a smaller pen here, is it's going to add an n to the numerators of the fraction to be multiplied by the numerators, and then over here with the 3 as well. So when I go to cancel, I will see the n's will cancel out here. I'm left with a 6 equals. When I look at my other fraction here, the n's will cancel, and then plus the 3 times the n. And now I have a very easy equation to solve. So subtract 1, I get 5 equals 3n. Divide by the 3, and I get 5/3 is equal to n. When I look at the second example, I look at this, I've got x in each of the denominators, and I also have a 3 over here. So I'm going to need the 3 and only one x, because I just want what's in common, or what needs to be common, and I already have an x that is common, and the 3 is not in all of these, so I just need the 3 and an x to distribute. When I distribute, I will again be adding a 3n to all the numerators, not n, but x. So I will have 3x in each of the numerators, along with whatever current numerator is there. And in the first fraction here, we can see both the 3 and the x will cancel. We're left with the 1. In the second fraction, the x from the 3x will cancel, leaving me with the 3 and the x plus 4 that's already in the numerator. So 3 times x plus 4. And then over here, the x's will cancel, and I'm left with 3 times 1, which is 3. I'm going to distribute the 3. I get 1 equals 3x plus 12 plus a 3. 12 plus 3 is 15, so I get 1 equals 3x plus 15. And now I just solve, minus the 15, I get negative 14 equals 3x. Divide by 3, and I get x is equal to negative 14/3. Looking at problem number 3, I have a 2, an x, and a 3 that are all different from each other. And so I'm going to use all 3 of those factors. I do not need to duplicate the x. So I'm going to have 2 times the x times the 3. And when I look at that, I have the 2, the x, and the 3. The 2, the x, and the 3. 2x and the 3. To be multiplied by each of the terms. And the 2x here will cancel out with the 2x from the first fraction, and I'm left with 1 times 3. For the second term, it's not a fraction, so I'm just not canceling anything out. It will be 1 times 2x times 3, which is 6x. And then the last fraction here, the 3 times the x will cancel, so the 3 and the x will cancel here. And I'm left with 2 times the 2 to get 4. So then I will solve this. I will subtract the 4. I get negative 1 equals 6x. Divide by the 6, and I get negative 1/6 is equal to the x. Number 4, when we look at this, I need to see that there's a denominator that needs to be factored. A squared plus 6a has a common factor of a in each of those two terms. So if I factor that out, I'm left with a plus 6 on the inside of the parentheses. Both the a and the a plus 6 are used in the other two terms also, and that will be our common denominator that needs to be multiplied times each of these fractions. And essentially that is going to, when you distribute, that is going to be part of each of the numerators. So a times a plus 6, a times a plus 6, and a times a plus 6. Okay, and once you distribute, you look at each of the fractions. So a times a plus 6 is the same thing as the denominator here, which cancels to leave us with the numerator of a plus 1. In the second fraction, we have a times a plus 6 over the a plus 6. So the a plus 6 will cancel, and we're left with 1 times a equals. And then the third fraction here, the third term, the a's will cancel. You're left with 1 times a plus 6, which is just a plus 6. So when we combine like terms on the left side, we get 2a plus 1 equals a plus 6. I will subtract the a. That will cancel the a out there. I'm left with a on the left-hand side. When I subtract 1, 6 minus 1 is 5. I am left with a equals 5. On to number 5. We have, again, fractions here. We have to see that this 3b plus 9 can be factored to be 3 times v plus 3. And these two factors are the same two factors that we have over here, so our common denominator is 3 and v plus 3. So we're going to distribute to all terms, so 3 times v plus 3, 3 times v plus 3, and 3 times v plus 3. So when we look at the first fraction here, 3 times v plus 3 will completely cancel out. We're left with that 1. With the second fraction, the 3's will cancel out, and we're left with 1 times v plus 3, so v plus 3. And with the last fraction here, the v plus 3 will cancel. You're left with 1 times 3 to get 3. So we add combined like terms. We get v plus 4 equals 3. Subtract the 4, and you get v equals negative 1. Now when we look at problem number 6, we see that there's a radical in this equation. And what we need to do is we need to isolate this radical and get rid of everything outside of it. So we've got this negative 9 being added. We need to, well, it's negative 9, so we're going to add the 9 to both sides. And that adding the 9 will get rid of the negative 9, and we get 8 is equal to the square root of r minus 5. Now the only way to get rid of this radical, we cannot do anything with r minus 5 until we get rid of this radical. And the only thing we can do with the radical to get rid of it is to use an exponent. So we're going to use an exponent of 2 on both sides of the equation. That will allow us to cancel out the radical, and now we have just r minus 5. And 8 squared is 64. And then we just add 5 to both sides, and we get 69 is equal to r. And same thing with number 7. We have this radical here. We need to get rid of everything outside of that radical. So we will subtract the 3, and we get 3 equals the square root of 9x. And again, the only way to get rid of the radical is to use an exponent of 2 in this case. And we get 3 squared on the left-hand side, which is 9. On the right-hand side, the exponent will cancel out the radical, and we are left with 9x. And then we solve by dividing by 9, and we get x equals 1. And okay, so then we look on to number 8. These equations have variables with variable expressions with exponents. So kind of like with the radicals, we need to get the variable expression that has the exponent by itself. So we need to get rid of the 10 and the 9. So we subtract 9. We will get 10 times n squared equals 810. And now we still have to get rid of the 10, so we're going to divide by the 10. And we get n squared equals 81. And now to get rid of the exponent, we will take the square root of both sides. And when we take the square root in the process of solving any equation, we have to include positive and negative of the answer to the square root of 81 in this case, which would be 9. So n equals positive and negative 9. Going on to number 9, same thing. We need to get the x squared by itself. So we will subtract 3. That gives us 10x squared equals 60. And then we have to get rid of the 10. So we divide by 10. And we get x squared equals 6. So then, take the square root to get rid of the exponent. And just like the other problem, we have to put in the positive and negative. And square root of 6. Now, if we could simplify the square root of 6, we need to do that. But in this case, we cannot simplify square root of 6, so we are done. Okay, moving on to number 10. We have n minus 3 involved with the exponent. So we need to get rid of the 5 and the 4 before we can do anything with the exponent. So we will subtract 5 from both sides. When we get 4 times the n minus 3 squared equals 144. And then we divide by 4 to get n minus 3 squared equals 36. So now we have the variable expression by itself with the exponent. Now we can use the square root, and we get the radical is canceled out. We get n minus 3 equals positive and negative 6. Now, because we still have to get n by itself, and we have 2 answers over here, we have to write up 2 equations to solve, one having a positive 6 and one having the negative 6. So over here, we're going to add 3, and we get n equals 9. Over here, when we add the 3, we get n equals negative 3. So 9 and negative 3 are the 2 answers. And then finally, with number 11, same thing. You need to subtract the 9. We get n squared equals 50. When you take the square root of 50, you'll be able to simplify that because 50 is 25 times 2, and the square root of 25 is 5. So we end up getting positive and negative 5 times the square root of 2.